In this video we provide a very brief introduction to the solid state and we discuss various types of solids that are found in nature. Alright, so when we think about a solid, discriminating factor of a solid is that it does not occupy the volume of a container and neither conforms to the shape of the container. And that makes a difference with the liquid, where the liquid would not occupy the volume of a container, but it would conform to the shape of the container. There's another more interesting difference between solids and liquids, and that is that even though the densities are pretty similar, in the solid, the atoms or molecules that are forming that solid, or ions, those particles cannot move past each other, but in the liquid phase they can. Right? So there's a difference in the kinetic behavior of the components of the liquid or the solid, which is important as well. Right? In general, we can distinguish between two types of solids, those that are crystalline and those that are amorphous. Okay, so amorphous solids we are not going to study at the general chemistry level. The ones that we're going to be studying is the crystalline solids. Right. So crystalline solids are interesting because the atoms or the ions or the molecules, the particles of that solid, occupy sites in a lattice that is regular. Okay, so for example, a really brief or a really simple representation of a lattice would be something like this in 2D, in which you see that there's a lot of periodicity and regularity in the lattice. Right, and that's a characteristic of crystalline solids. In amorphous solids, there will be a complete disorder of these particles of the solid. They will be completely scrambled and at random. That periodicity and regularity is lost. As a matter of fact, you can take any crystalline solid and reduce it to a fundamental unit, which we call unit cell, from which you can generate the entire three-dimensional coordinates of the solid simply by replicating in space that unit cell. Okay, so that is a characteristic of crystalline solids. Right, within crystalline solids, what we can do is distinguish types of solids according to the particles that are in the lattice sites. Okay, so here we're going to talk about ionic solids, atomic solids, also called network solids, and then we're going to have molecular solids. Right, so the distinction between ionic and molecular solids is fairly straightforward to make. What happens in ionic solids is that in the lattice sites you have ions, and in molecular solids you have molecules. For example, a case of an ionic solid would be sodium chloride, and then a case of a molecular solid would be a crystal of sucrose. Okay, so when you take a crystal of sodium chloride, what will happen is that in one lattice site you will have a sodium ion, and another lattice site that is nearby will have a chloride ion, and so forth. Okay, now when you try to dissolve the solid or melt it, what will happen is that the liquid that you get out of that will conduct electricity, and that is a clear manifestation that the particles, the entities that you have in the lattice sites, are ions in the solid. However, in sucrose, what you will have is that there will be an entire molecule of sucrose, which has this stoichiometry. Okay, so it will be a glucose-fructose dimer, okay, and it's not ionic. It's just a molecule made by two units of, one unit of fructose, one unit of glucose, and they will occupy, each sucrose unit will occupy a lattice site. Obviously, if you were to melt sucrose, because that's a molecule, not an ion, that melt would not conduct electricity. Okay, so again, that is the distinction between ionic solids and molecular solids. Now, atomic or network solids are those in which in each lattice site you now are going to have a neutral atom. So for example, graphite or diamond would be a textbook example of an atomic or network solid in which at each lattice side you just have a carbon atom that is neutral. Now, something that is important about atomic and network solids is that the bonding between those species, between those atoms that you have in that lattice, that will be covalent. Okay, and that makes a difference with ionic solids and molecular solids. In ionic solids, right, so this is sodium plus and chloride minus, the interaction between those would simply be ionic and governed by Coulomb's law. If you have molecular solids, so for example, if we were to get here a crystal of nitrogen, N2 and N2, right, notice that the interactions between them will not be covalent. Okay, they're not sharing any electrons. They're not ionic because these are not ions. Instead, there would be intermolecular interactions. In the case of nitrogen, that would be of the dispersion type. But for example, if you have sucrose, sucrose can establish hydrogen bonds between one molecule of sucrose, another molecule of sucrose, again distinguishing the type of interactions in the three solids. Again, here you will have electrostatic ion-ion interactions, Coulomb's law. Here you will have covalent bonds; those will be very strong. And here in the molecular solids, you will have non-bonding interactions of the hydrogen bond, dipole-dipole, dispersion interaction type. Right, so in this video we have provided a very brief introduction to types of solids. We've said that in principle you have two types, amorphous and then crystalline. The ones that we're going to be studying in more detail are crystalline, and those are the ones whose entities can be put in a lattice that can be minimized to a minimum unit called the unit cell. Okay, within crystalline solids we're going to have ionic, atomic and molecular, and that concludes our introduction to solids.